Okay, my friends, another one of those hard to believe coincidences about woolly mammoths. Well, mammoths in general. And there is a couple of different types. And I'll show you what I did long ago in relation to the woolly mammoths and their DNA and so forth in relation to my research. And I'll give you the details. Okay, if you've been hanging around here, you know that I've had DNA tested and CAT scanned human beings that were from the Great Flood that tested positive for human DNA, and excellent quality DNA of giant, very giant human beings. Giant. Now, this is about the Ice Age Americans. How did they survive? And they're talking about people similar size to us, maybe a little bigger, I don't know. But they survived on mammoths. And they were thinking, this is a big revelation, we just figured this out. And this is from the University of Alaska in Fairbanks. It just came out today, moments ago. And, I follow all these little discoveries that they claim to have just found. Now, they claim that they have butchery areas where they just could just slaughter these things, no problem. Huge animals, and they had a certain way of hunting them and so forth, that they got it all figured out now what they did. And the researchers found direct evidence that the Clovis people relied heavily on mammoths for food, using isotopic analysis to confirm 40% of the Clovis mother's diet came from mammoths. I'd like to see how they can figure that out. The study highlights how hunting large animals supported the Clovis people's mobility and rapid spread, which also contributing to the extinction of the Ice Age megafauna. It went extinct. So we need to find out, when are they talking about? What is Ice Age? What does that mean? When does that happen? What is their interpretation? Now, here's where I come into this, because I studied with a guy that was supposedly the experts on mammoths, both Colombian and woolly. Let me show you that in a second. Now, I took a course at Johns Hopkins University, and Stephen Salzberg was my professor. And, we had conversations back and forth about his discovery of this interbreeding of the Colombian mammoth with the woolly mammoth. So I sought him out as my professor to discuss with him my DNA reports of the human DNA and so forth, and I thought maybe he could work with me, and I sent him my reports and my DNA analysis, and the whole thing, pictures of the specimens and the CAT scans and all of that. And I thought I was pretty concise and as brief as I could be to show him that I had evidence to support my statements, the DNA reports and all that stuff, and that they appeared to be giant human beings at this time when there was giant woolly mammoths. I thought he might be open to that to some degree. And of course, he's doing the interbreeding of the Colombian and the woolly, and what I took was genomics. He was the professor for the genomics course I took, to understand the human genome, which is the program. All this is a program, simple as that. And now, this was 10 years ago. And anyway, it didn't end well. It never does. Within 8 minutes, I got a response that was just staggeringly arrogant. And anyway, I don't want to go through this. I never had not one good response whatsoever. Wow, let's think about this. Let's look at this. Where'd you get this? Not a question. No questions ever. Never a question. Zero questions in all this time. I am told that I am wrong, and I contaminated this, I contaminated that, I don't know what I'm doing, I should get every kind of demeaning comment you can think of, and never a question. I'm not kidding you. This is stunning. All right, now, when I first saw this, it's clearly was going to be an arrowhead, but when they started working this area here, there was a bunch of blood literally inside this tissue. This is tissue, and it's layered this way. And if it's a good stone, it'll be layered deeply that way. And then it'll be layered, layered, layered. This ran into like a blood vessel. And when they started flaking it off this side to make it come up to a regular arrowhead, it just fell apart, so they left it here. And they found this. Now, how big would a creature have to be to have an arrowhead this size? Is it a spearhead? Is it an arrowhead? If they had a guy or 5 guys with a pole like this big, running up and jabbing a woolly mammoth, that might work. Who knows? They didn't. At first I said, they had to be giants. Well, maybe not. But this is clearly something that didn't work when they started flaking off this side. This is exactly, and I had people respond to me saying, yeah, there's no question this was being worked to become an arrowhead, and this made it not usable, and they just left it here. Which is, what else are you going to do? So they could have been hunting mammoths with something like this. I don't know. Okay, my outstanding friends, we are entering a new era. I had DNA tests done on 3 specimens. This one, and a huge, huge fingertip. I extracted the samples from them and sent them off to be tested. Now, the objective of this analysis is to perform extraction of genomic and or mitochondrial DNA from 3 mudfossil samples. Upon successful DNA extraction from the samples, which I sent him, I didn't send him the pieces. I sent him what I extracted, and he did the analysis. And it includes amplification, extraction DNA using PCR technique targeting specific DNA marker sequences that showed that it was human, to obtain DNA sequences from the amplified PCR products. And it is a very detailed analysis of this. You know, it was expensive, and it was and well done. I'm very, very pleased with the, how they reacted and took care of things. All the negative controls were negative, and the lab director there told me that there was 2 of them that were excellent quality, and this one here was not quite as good. And they did whatever they do, I don't know, but they came back saying that they submitted these sequences to somewhere, to a national database, and it came back that they were all human, all 3 of them, which is the mitochondrial DNA, which means the mother's side is virtually like a modern human. Now, excellent quality DNA sequence obtained from the 36-inch tip. That was the gigantic one, and the lung sample. And the other one, the quality of this one here was a little less. Now, this is what it came back: Homo sapien mitochondria, cytochrome B gene, and D loop region. For both of these, that's what he's showing. And then this is the actual CTAG sequences of the DNA. And he said it was excellent quality. So this is pretty good evidence, and the anatomical look of them is just undeniable. And this was back in 2015. Now this is what I sent off to my professor there at Johns Hopkins, and I also sent him some CAT scan pictures and some all kinds of things. Of course, it was you can't have it, and that was it. From then on, once you get a reaction that is very negative, and they've all been that way, there is no talking. What are you going to do? You beg them? No, you can't, because they just think you're an idiot. So we went on our own ways. Now, I have the microscope all set up here. I just showed you the DNA reports. I showed you 2 of the samples. I have the hand and everything else that goes with this, and knuckles and all that. And I have a piece that is part here. See, this is where the bone is. You see that round part there? That's where the bone is. All right, this is the side that goes up the edge, which has the tendon strapped to it. And it's broken off out of here. We can actually see the bone. And you see the difference in the transition between the bone and the actual tendon? We're going to look at this in a microscope and put some water on it and all that, and we should be able to see. And there's blood right here. You can see, you see that red stuff right there? That's blood. And it's all over the place. You know, they all have blood coming out of them. And the huge fingertip, I smashed into that and got down inside. And fingers, and of course lungs and hearts have just tons of blood. That's why you can get blood out of these no problem whatsoever. And the ends of your fingers are just saturated with blood. Fingertips are soaked with blood. All right, this is the fingertip that came from this hand. That is the left hand. This is where the little finger comes down. It's broken off right about here. All of this is gone. Right? This is right here. So it's broken off. All the fingertips are gone. And this is what that is right here. This is the pad of your hand, and that's the cleave in between your hand. This is the tendon that runs right down. If you lay your hand back like that, you're going to have that tendon run right there for you too. And this pad is the same thing. It connects and the tendon runs right down. And this is another pad that just runs off here. All right, so this is the pad of your hand. Let me back it out so you can just see it. There's a couple of bones coming down here. Those are those bones that are right over here. This is all really fleshy. See how the color of it? And then there's that little pincher right in between the 2 pads. Now this is that tendon I talked about, runs down your left hand. Put it back, there's the tendon right there. That's it. All right, and this is the little piece that runs off, this little part here that runs down to there. Not hard to understand what you're looking at, but it's broken off right about up here. And all you have is this little hook here. The thumb ran off that way. And I have knuckles and fingertips and all kinds of things from this. And this is what I had CAT scanned. And I will show you in a second in the microscope. Now you see this silvery stuff? That's called grip skin. A grip skin coats your hands and your feet and your fingertips and like your elbows and wherever you have a lot of scratching and moving around. That's the tough skin. And it peels off. It's made to be used and expended. Now, I'm going to show you my giant fingertip. Where do you see this? This thing it's about 3 feet wide here, I think about 4 feet wide up here, something like that. This goes back a long time ago, and my mind is not as sharp as it used to be. Now, you see how this is all silvery and flaking up? See how it's just peeling off? It's like a coating on it. Somebody painted it, and the paint's peeling. Well, it's not too much different than that. That is just like a glove on your hand. You have this grip skin, and it's just meant to be scrubbed and scratched and torn up and fall off. But underneath is saturated with blood. Here's what's underneath your fingertips. That's just completely saturated with blood. But then it's just like a rubber glove around your hand. Now, I told you the big fingertip I smashed. That's this one here. Check that puppy out. Now, what are we looking at? Well, it's a fingertip. You say, well, I don't see a fingertip. Well, take your time. Take your time. This is the round part of the end of a fingertip. And it's nicely kept. Now, when I found this, I could see the fingernail came around here. You see it over here? It's a little eroded over here, but not much. You can see where it, if you just follow the natural inclination of the curve, you can see how that works. Right? Sometimes you have to stand back and look at things. Now, that's the fingernail, and like I say, not too bad. He kept it up pretty good, or whoever it was. Now, this was entirely intact when I first found it, and I said, wow, that's looks like a finger. And this little pad right here in the back is where there's a little rocker that, it's like a pad in between so that your bones rock on it. I forget what they call it. It's like a cartilage type of thing. Now, this is the vein and the artery coming up here to service the blood right at the bottom here. There's a big pool of blood right here. And then there's other areas that have blood coming up too, but these two are important. And you'll see right underneath the back of your fingers, there's a lot of blood right in that area. Now, so I couldn't get any blood off here because it was really, really, solid, like granite looking, whatever you want to call it, basalt. But it feldspar. Anyway, I decided, well, I'll just break it off because I could see there was a crease here. And I figured, well, I'll just take a big size sledge and smack it and it'll pop right, something will crack and it'll fall off. I'm kind of a butcher when I do things, but it works. So I whacked it and it just popped off like a scab. I mean, literally like a scab. And here's what it is. When that came off, it still had the fingerprints on it. All right, here's the fingerprints. There they are right there. All right, this is the grip skin. I said that it just peeled right off. You saw how that silver stuff was peeling off the hand. Same thing here. And these little things here, you know how you get your palms getting sweaty, your fingers get sweaty. That's the sweat pores. And there they are right there. And this is just the fingernail is right up here. So it's just barely off the fingernail we are. And this is big. My thumb is the same size as one of the finger ridges on a fingerprint. One of these. My whole thumb is only one of these tiny little jobbers. So this thing's big. This thing's good size. It's 3 feet long. The fingertip is 3 feet long. I figured it out to be 180 feet, something like that. And I have other stuff here from giant creatures. I'm not necessarily saying it's human. This one, no question, was human because it was DNA tested. And I got one here around here somewhere. It's here it is. Hold on a second. This is a hair follicle. It's 2 inches wide. And that is a hair follicle. Of that, there is no doubt. From what kind of creature, I don't know. Okay, shown this a zillion times. Very easy to show, very quick, simple. This is the hair bulb. This whole thing right here is the bulb. All right, that little thing right there comes up and becomes the hair shaft. You see it? Those little 2 dots right there. There's one there and there's one there. You see the little circles? Those are the hair papilla, which is the vein and artery, blue and the red. Now, on this side is the sebaceous gland. On the other side is the hair muscle. This is the erector pili muscle. And there it is right there. That's how muscles attach. They have a central core and they have a whole bunch of fibers around them, so you can really pull hard against this and the muscle won't rip out. And the center core is really embedded in there. So there is the erector pili muscle, and your hair goes, ah, when you get all upset. Ah, your hair stand up on edge. Well, what's going on over here? Well, the sebaceous gland. Now, it would have been a little higher up, but it slid down, and it's just a bunch of gooey sebaciousness right in this area. And of course, there's the hair coming out the top, and it's got a flat side on it. You see it's flat? And They tell me that that indicates it is a curly-haired person. But to me, there's nowhere, you can't doubt this. There's just no way to doubt these things I'm showing. And with the CAT scans and the DNA and the anatomical features, and it can be retested, but it's denied for 15 years. I think it's time to get off this nonsense of denial of reality. It's just that it doesn't work anymore. Now, just an FYI, I have a friend, a Russian friend, who's interested in where the DNA of these human beings came from. Where did this DNA come from? Now they're doing these ancestry kits and so forth. So I got like 6, I guess I got a dozen of them coming, but I got 6 of them coming today. And I am going to show exactly how I extract the DNA. And we're going to send it off and see if they can say where it came from, or even if it's human. Now, this is a no-toe. This is not a standard human foot. It's got rounded toes, and they're built inside this fabric, but it's damn close. And it had a tibia and a fibula. But other than that, it has springs instead of bones. And we have other ones too. But it's got a built-in sole. I mean, this is bizarre stuff. I'm sorry, it is what it is. And it died on its side, this side right here. Just like all the stuff in the flood, they got one flat side. You see that? This lung, DNA tested. This isn't standard human size. Now, did this lung go with that guy's foot? Could he have a lung like a human and a foot like a no-toe? I think it's possible. And this thing's is saturated with blood. I mean saturated. Because that's what lungs do. Now, I'm going to show how you extract using masonry drills, basically. You got to make sure that they're exquisitely clean. And you drill one, blow it all out. You don't wash it or anything, you just blow it out. And then you drill another one inside the other one. So you got a wide one and a smaller one. This one goes in, and you blow it all out good. And then this one goes in, and then the residue from that is what you use to see whatever DNA is in there. So it's not going to be contaminated. We're going to be getting inside of them. And that's how I do it. I don't take it from the surface, obviously. You know, I go, oh, you're contaminated, you don't know what you're doing. No, I know what I'm doing. And when I do it, I'll wear gloves and a mask and all that stuff. Really, it's simple to do. It's just not a big thing. You don't have to be any expert to do this. You just have to take a little time, do it right. And I'll show you what I am doing, and you say, well, yes or no. Well, it makes sense or it doesn't make sense. And when I'm going to be showing a bunch of different things, like I say, I got, I think, 12 kits coming. I'm going to test myself to make sure that I am not exactly the same as all the rest of them. Now, I don't know exactly what they give you, but they, from my understanding, and I'm not involved in this, all I'm doing is putting the bits and pieces in there, and whatever happens after that, I will see the reports later. But my understanding is the only thing that they look at is human DNA, and then they say all of these little bits and pieces of that DNA mean that you came from Indonesia, or your ancestors were from here, and 16% was from that region, and 20%, like they did with my dog. He looks like a Labrador, but he doesn't have any Labrador in him at all. It was interesting, but he got like, I don't know, he's a mutt, you know, nice dog. Nero, I love him. My best friend. All right, so anyway, that's what we got, and I'm going to show you how I extract them. I'll do each one of them, I'll name them. They'll be sent off, and we'll see what the reports come back. They maybe come back and say, this is not human, you're an idiot. We'll see. Okay, so like I said, I got about a half a dozen kits coming. Well, I have a half a dozen kits coming today, and I think another half a dozen kits of these DNA kits. Now, I showed you what's in the fingertip. It's absolutely saturated with blood. There's the 2 spots I showed you with the 3-foot long jobber. Now, this is another fingertip, and I'm quite sure it's human. Right there is where an apical tuft goes. I don't know if you can see these little details or not. But this is where there's a big infusion of blood, and then the apical tuft sits there. And the apical tuft is one of these. It sits right here, and it's a whole bunch of little balls locked into it. It's right at the tip of your fingertip. And that's like where the fingernail would have covered that. Now, remember I showed you, these are just that's all blood. Well, guess what? So is that. You see all that red stuff? That's blood. It's not red for no reason whatsoever. That is blood. Now, that is it's transitions. It's nucleophilic being substituted. However, blood doesn't transition the way the other stuff does. It's different. The tissues are different than the blood. The blood doesn't transition. Well, you can see it. I'll be showing this in a microscope and everything. But everything else gets invaded and transitions and stabilizes, and the blood doesn't stabilize. Now watch this. This is the tip of the finger. All of that red stuff will turn really, literally red blood. And some of it will actually completely rehydrate and turn into red blood. Now, what I'm going to be doing is drilling into here with a masonry drill down through where it's really red and bloody. And we'll remove all that. I'll blow it out. I got a compressor. I'll blow out. And then I'll go a little deeper with a smaller one. And that's what we'll use to do the extraction. Now, there should be DNA down in there. I'm telling you. And we will be into fresh DNA. Nothing will have been touched. I'll show the extraction on a video. Now, this is where the bone was. Totally transitioned. But you could see, if you got Mudfossil eyes, you can see where the bone was. That's the center. Then this was around the edge, on the outside edge. Down there is tendon. You see that? That's tendon. You see the different look to it? These are little ropes of tendon. And those go up to that apical tuft. And they embed in that so your finger can do all those kind of things. That's where those tendon balls, those tendon ropes go. And they lock in up in here with the little balls, the enthesis balls. Now, we'll find out. Is this? I mean, I know. I'd be very surprised if it doesn't come back human. If they know where this came from, I don't know. Could they possibly? I have no idea. But that baby is saturated with blood. Saturated. All right, now, so that's that one. We're going to be seeing that one, and I'm going to be doing this one, and I'm going to be, doing this one, this no-toe, and, I got a whole batch of stuff. And I look at this. Where do you see this one? This just stunned me. This is a guy's lung. That's his back. You see all the bones fragments in his back? This is all bloody stuff. He was laying like this. He died in the Great Flood. Everything was boiled off him except this, which was sitting in the mud. And even little bits and pieces of the bone were preserved. Very rare, any bone. Now, so he's in there like this. His whole body boils off. And all the flesh goes, and this is where the runny little fleshy stuff running off. And over here you can see that's where the alveoli are in there. There's still some little cavities in there. And then you can see the spur lock. And it is absolutely flawlessly perfect where this thing latches together. I'm going to show that in the microscope in a second. You can see the totally different between where the spur lock comes down, and well, on the side it's easier to see. It comes down here from the lung and latches down below. If you can see that triangular look. But you can see it's totally different material. This is like this is the lung, and this is the body flesh on the back. It's quite a bit different. Whoops. Can you see that? Can you? It's quite a bit different material. Anyway, we'll take a look at that later. I got a lot of stuff, my friends. A lot of stuff to look at here. And the microscope is the best place. But what I was trying to show you before, I don't know if you can see it or not. Let me try to find it. Here we go. Right there. You see that triangle coming down here? That's the spurlock. It comes from the lung, and it latches. One of them comes up this way and latches, and another one comes down this way and latches. That's what hooks them together. It looks like to me. This is sort of new. I just noticed this today, actually. And I believe that's where the two transfer spots are for the fluids between the membranes. Because they have to transfer those membrane fluids. Now the membrane is gone. We're down to the alveoli. The membrane is pretty much gone. So we're a little bit deeper than we would be if we were in this one here, which is pristine, but it also still has that spurlock. You see the triangle coming down here? And this one over here is a piece of flesh, if I can find it. There it is right here. And that's the spurlock on this. And that's the little gnarly spot up at the top, and that little triangle comes down and it latches. And there's two little tiny spots that are little tubes at the end there that flow the fluids into the next membrane. It's one giant system. I wrote about this in 2015. This in the muscle is still tied into the fluid-filled highway of the lung. Everybody's tied in together. It's one giant system. The fingertips, this, everything in your body flows through this fluid-filled highway. And where they attach together at organs where they meet the body, like this one here, where this lung attached to the body is right here, right in the back. All right, and at that point, it locks into the body, which has all this bone and tissue down here. It's totally different stuff here. And that's why right there they seam together. And it looks to me like now, the way I'm looking at this now, one seams against the other in like two little triangles. All right, so they're coming together like triangles, meeting together. I don't know. I'll show you in the microscope. That's what I'm seeing now. And I may be able to see some more stuff that I missed before now that I've come to that awakening. But once I do the extraction and we see if these things have human DNA, and where did they come from? Are they from some special place on the planet? Would they even know that? Would they have any idea about that? I don't know. That's kind of interesting. You see that spot right there? That must be part of the, well, I can tell it's part of the tendon. You see where it is right there? We could look at that in a microscope. But I can tell you that's part of the tendon because it comes back here and these are all the tendon fibrils. You should be able to see that. You see those little fibrils right down the bottom here? These things here? Right above it was where the bone was. You see the round part above there? Down underneath of it is the tendons. That's where the tendon fibers go up. Each one of these is a round tendon bundle. And this is still it must be part of that tendon, looks to me. And they come up and they lock up in that, right in this spot up here, but underneath at the bottom. They have under the bottom and they have over the top. Anyway, we'll find out if it's human or not, or what it is. May just come back and say, well, there's nothing we can tell about it. Like I said, I am done doing DNA tests myself. This is, somebody else is paying for this, and I'm staying out of it. Do what you want. There is some clause in there, whoever's doing this, that they don't use your DNA for anything, and I hope that is the case here, because I'd hate to see them do something crazy with DNA of these kind of things, because these are, in the ancient texts, some of these are not good people, or good creatures, or whatever you want to say. There's good and there's bad. How do you know which one you got? This just doesn't get any better than this. I've had this lung laying around here for a long time, and it's got the guy's back is still attached. This is the lung where this was exploited. It was laying like this in mud, and it boiled off all the flesh down to the alveoli of the lung, and this is some red, meaty, fleshy stuff that's still here and turned into like clay. So I'm thinking, well, and I've seen this on the back here. The back is still got some bone in it and stuff like that. Extremely bloody, nasty body flesh. Now, so you got a fleshy layer, and then you got a lung, and you can see it over here. You see the fleshy layer here? And right above it, you got your lung with the little alveoli holes. Now, this has got the spur lock on it, too. And there it is right there. You see that triangle coming off of here? And it wraps right around, right to there. You see the triangle? Can you see that? There's the triangle coming here. Not only that, I believe these are the two spots right there where the fluid transitions from this bag of what used to be fascia through those two spots into the next bag of fascia, which is wherever it is. Now, look at the transition zone. You see the lung here? And then there's the guy's back. Now, this is the spur lock right here. This little triangle that comes down, it latches this piece into the back. So it's nothing more than like a snap. And this right here is the really tough spot. Right there, locks in. And then the flap comes over. And the flap comes over like this and attaches to the body part below. You see it? That crease right there? That is the spur lock, and I believe that's where those two little dots are, that are the fluids that move. They're two different colors, and I'm pretty sure of this. And that is the seam between this lung and the back. That seam right there. So that was a guy's lung. Or some lung of some creature, and it looks humanish, I don't know, but it certainly has a spur lock on it. And of course this does too. Now this is from, I believe, the other side of the lung, but I don't know. But you see that strap coming down here? This has got the same thing right there. You see that strap? And then there's the spur lock right there, that little triangle coming right around here. Same thing. It's got a lot of blood in this one. Really fleshy. This one here, and of course it all rotted away. But if it had been new like this one, you know, this is virtually brand new. You could almost transplant the damn thing. It's so perfect. But it died in the flood again, but it was in a certain area where it didn't get boiled off like this did. I can't tell you why. They're all here on the same property. I picked these up right off of my property. I didn't have to go anywhere. Somebody says, oh, you guys should go on site. Well, I'm on site. You know, I'm on site. I don't have to go too far to get to the site. I don't know why they all came off here. Now, some people have sent me stuff, yes, and I always make sure that I say this came from so-and-so at such and such a place and whatever. But most of the stuff is right here. This no toe came right off of my property right here. That's the guy's foot. It's even got a sole built into this guy's foot. I mean, this is built in. Now, I'm going to take a DNA test out of here, and I'm going to drill right into where the toes would have been. You know, with a masonry drill. Way down in there. And get some, I think we can get some DNA out of it. Toes are saturated, fingers are saturated, lungs are saturated. Wherever there's blood, there's preservation. I'm telling you, the blood is fabulous. I'm not going to get this tested. I don't know if there's any DNA on this at all. This has been so transitioned. But it's a giant hair follicle. I think I showed you this. The anatomical. Anyway, this is all serious stuff. This is not a joke. And it's nothing, you know, these woolly mammoths, big deal. What does that mean? Of course they ate something. You know, I don't see that as a big factor here. Now here's another thing. They were making a big deal out of this. Scientists discover oldest modern lizard fossil, shaking up evolutionary history. Well, I think I shook it up a little bit. I think my stuff would shake it up a little more than some little lizard. Here's the other thing. Unveiled by ancient DNA, the true timeline of human Neanderthal interbreeding. Well, let's find out what the stuff I have here is. You know, they're getting ancient DNA from wherever they are. I should be able to get it from my stuff. My stuff is probably much more credible than the stuff they're getting their ancient DNA from. All right, this is the DNA tested and CAT scanned human lung. And it came back human. And I have the DNA reports. I think I've shown them to you. Now, I have it in the microscope. We're looking down at the edge here. I have to turn the lights off, so we're going to lose it. Hold on. All right, now, up in the microscope is that lung. All right, now it's got to home in for a second. All right. Now, I'm going to point out things as I move the scope in and out. Right here is the fascia. That's the fascia that coats it. You see down in here, this is the lung. This is actually the tissue of the lung down in here, where the alveoli and the air would flow through there and the blood would exchange. Now up here is the outside skin, the fascia that coats it. This is just saturated with blood. I mean literally saturated. Now I will drill down into this, but let me show you something. It's probably going to wash out. Let me, here we go. I'm going to put a little bit of water on there and just give it a little scratch, and you'll see I'll try to stay up in this area here if I can. And you'll see it'll turn red right over. I mean, you can see it. Look how it sucks that stuff up. Let me turn the lights up. You see how it ate that water up like it loves water. Let me do it again. All right, now the water's all over it. Let me scratch around here. Whoops, I can't find it. Here it is. All right, that'll just turn into blood. You see it running over there, the blood right there? You see the blood coming out of it? It's like it's almost bleeding. I'm having a hard time finding the spot in the microscope. Here it is. You see that? It's just like bleeding. It's just like blood coming out of there. Now, I will do that, but I will do that from inside deeply, so that there's absolutely no chance of contamination. You see how quickly it eats up that water? Watch that. It's just saturated with red blood. So this, and I had already have this as tested, so it's not like it's a big deal. So that's going to be one of them that'll be tested. Now, let me see if I can do something with the other lung. Anyway. Okay, this is that green, I believe it's olivine, they would call it, fingertip. And we're going to be looking down at some blood. Because this is where I'm going to be taking blood, but I'm going to be drilling. Now, this is the tip of the bone right there. You can see the bone? If you get it in the right shadow, you can see it pretty easily. And then below it, you have your tendons. You see those little bundles there? Those are little bundles of tendons. And that's right below the bone, which is right there. Now, we're going to be looking at this blood up in the microscope. And there's one little, see that little white spot right there? That's the only piece of bone I can find in this whole thing. You know, you can see it, it's quite obviously bone, but I don't know why that little spot preserved. But I don't care about that, I just think it's interesting. Now, we got all this red blood, you can see it all over. I'm going to turn the lights off, we're going to get in there, I'm going to put a little water on there, scratch it up a little bit, see what we see. But again, I'm going to be drilling down inside, so this is just to see what we can see on the surface. This is not where the DNA test will come from. It will come from inside, drill down, masonry drills, and get way down inside, and then get all that, blow it out with an air compressor, and get down in there and take some more. And that's what we'll submit. All right, we're looking at that there, and this is up in the microscope. And again, this is not meaningful. It's just that I find it interesting that that's one little spot of, it looks like bone, but it might be just silicates. You know, now that I'm looking at, I would say that is silicates. So somehow, well, I have to look at it a little closer. Yeah, I'm going with silicates. I don't see a bony structure there. Do you? I don't know. I'm going to go, I don't know. But I can tell you what, we're going to look at this stuff here and scratch it up and see if we can get a little bit of blood reaction there. With my, oops, that's what fell down is my scratcher. Hold on one second. Well, that scratcher fell into the bowels of the beast. I can't find it. However, I have a backup scratcher. Now, I'm going to go in here, right in this area. Let's see if we can just move some stuff around and see if it turns bloody. Don't forget, this is surface stuff, so this is not like it was going to be when I drill down inside. But I can see it's turning bloody. You see it? I'm not really scratching it hard or anything, but you see all the little blood particles? I believe they were actually coming out of an artery there somewhere. Once you scratch the surface, it's just like you open up a cut. The other one, I mean, just the blood just absolutely runs out. This probably would too, given it a little time. You scratch it a little bit harder and see what happens. Originally, I was just sort of ruffling the surface. You see all those little particles? That's the kind of stuff we're going to be submitting. There should be DNA in there. I mean, this is red blood. Now, I'll bet if I put catalase on, hydrogen peroxide on that spot, we'd get a catalase reaction. I'm not going to bother. Let's see what happens when we get the DNA test and the results. Who knows? All right, what you're going to see in the microscope in a second is this piece right here. And I'm going to show you the interstitium spots at the bottom where the fluids transfer and how all these straps come together to latch and hold really strong. This is an injured spur lock. It's ripped here. It shouldn't be ripped. It's the same thing as this, only it's coming, well, I don't know where it is in the body, but it's a ripped body part. That's it, probably going to a tendon. And this I would imagine is as well. Now, this of course is a rock, and that is actual flesh. Now, we're going to be looking over in the microscope here at that rock, and we're going to be looking at it up in the screen, and I will show you that these exact features. This little triangle coming down, the two dots, and the spur lock is the really latchy, heavy-duty spot is up here. And this one has one here too. This is what really locks it in, and then this brings the fluids down and attaches into the next part, and it isn't a lot of more structure here too. I'll show you how these straps come together. They're very, very tough. All right, what you have to understand is this is not meant to be this far away, this microscope. I sort of did some things to it to make it so that I could see this far away, and that is the thin film of fascia that eventually coats everything in that muscle. It bundles up here. You see how it's bundling up? These straps are coming together. This is the really tight spot where it comes together to make the spur lock. And that is the spur lock. This right here is a heavy duty, really heavy duty latch. You see it? You see how it indents there? That is a really, really, really tough latch. And that's where all the tendinous fibers come together, which are tough as hell. Now, they continue past the latch till here. And at the very end, there's two spots. I'm going to come in on this close. You can see them right now, but those two transfer the fluids into the next body part. And that body part wrapped around and is partially still here. They have to hook together. And it looks like that's a remainder of that part that hooked into this part. Let's look at it closer. But that is tough. That's the spur lock up at the top. Well, the whole thing is a spur lock. This is the latchy part, and the bottom part is the fluid drain part.